In this section, we're going to look at what is meant by two or more events being mutually exclusive. Mutually exclusive events mean that if one of the events happens, the other cannot, like getting a head and a tail on a coin. If you toss a coin and you get a head, you can't also have got a tail. So with mutually exclusive events, if one event happens, the other cannot happen. On a Venn diagram, mutually exclusive events look like events A and B. We can see there is no overlap. Therefore, A and B are mutually exclusive. Mutually exclusive events on a Venn diagram have no intersection. They are completely separate. On the other hand, if we look at C, C does have an intersection with both A and B. Therefore, events A and C and B and C are not mutually exclusive. One classic case which we have met is the case of A, the event inside the circle, and its complement A dashed, or not A, which is outside the circle. Clearly A and A dashed are mutually exclusive events. To underline this, consider that A is the event getting a 6 when we roll a die, then A dashed is the event we don't get a 6. When we roll a die, we can't both get a 6 and not get a 6. We've seen that there is no intersection if two sets are mutually exclusive, and that implies the probability of A intersection B is 0. This has a consequence for the addition formula. The probability of A or B we know is the probability of A plus the probability of B. Take away the probability of A intersection B. Clearly, for mutually exclusive events, the probability of A and B is 0, just leaving us with the probability of A or B being the probability of A plus the probability of B.